Alright, calculus students, welcome to the continuing series of videos on the chain rule. And in this video we are going to take the derivative of this function k of x, and this is going to get pretty gnarly because it uses both the chain rule and the quotient rule. So let's go here. K prime of x is equal to, using the quotient rule, the derivative of the numerator, which is just 1, times the denominator, which I'm going to write as x cubed plus 4 to the 1/2, minus the derivative of the denominator times the numerator. Okay. So I'm going to take the derivative of the denominator over here on the margin here. So if I have, let's call this other function h of x is equal to x cubed plus 4 to the 1/2, then that means its derivative must be 1/2. You got to take the derivative of the outside function, x cubed plus 4 to the negative 1/2, times the derivative of the inside function, which is just 3x squared. So this result comes up here, because we're back to this problem now, the original problem. We want to take the derivative of the denominator, which is 1/2. I'm going to call it 3/2 x squared. I'm just multiplying the 3x and x squared and the 1/2, times x cubed plus 4 to the quantity negative 1/2. And then all of this is being divided by the denominator squared. So this is the square root of x cubed plus 4 squared. Okay, so there it is. That's the derivative. But we cannot stop there. We cannot stop there if we want to use this function meaningfully in some sort of efficient way, and we cannot stop there if you're taking the exam either. Okay? So there is a ton of simplifying that needs to happen from this point on. So the first thing, so I'm going to continue it down here, k prime of x. Let's use a different color. So in the denominator, that's just going to be x cubed plus 4. In the numerator, oh wait a minute, I think I made a mistake up here. Let's see. So the quotient rule is the derivative of the numerator, which is 1, times the denominator, which is all of that, minus the derivative of the denominator, which is this thing here, times the numerator, which is just x. So I forgot to multiply this here by x. Okay. Alright, so now, so this should really be a negative 3/2 x cubed. Okay. But no troubles. We found a mistake, fixed it, and we can move on. So on the top, it's going to seem kind of crazy, but we could actually factor out a x cubed plus 4 to the negative 1/2. Okay. So we're factoring some pretty complicated looking things now. So if we pull that out, what we're left with here is just 1. No, I'm sorry, this is not 1. This is going to be x cubed plus 4. Okay. This term right here just becomes x cubed plus 4. And you can think of it this way, as if you were to redistribute, or you take this x cubed plus 4 to negative 1/2 times this entire term. This is really x cubed plus 4 to the 1. If you were to redistribute, you would in fact get x cubed plus 4 to the positive 1/2, minus, this is 3/2 x cubed, because you have a x squared and an x here, and there's that. Okay. Then there's maybe a little bit more simplification that can still be done. We could certainly, we're going to take this negative exponent here and bring it down into the denominator, and what we will get is x cubed plus 4 to the 1/2 to the positive 1/2 times x cubed plus 4. In the numerator, this is just x cubed plus 4 minus 3/2 x cubed, and some more simplification that can happen. You got the x cubed and the negative 3/2 x cubed, so that's 1 negative half, negative 3/2, so that's negative 1/2 x cubed plus 4. And then in the denominator, this becomes x cubed plus 4. This is really to the first power, so this combines to the 3/2 power. Okay. Now what we typically want to avoid is fractions within fractions, so I'm going to factor out a negative 1/2 on the top, and that leaves me with x cubed here, and this leaves me with negative 8. All of this over x cubed plus 4 to the 3/2. And in my last step, what I'm going to do is take negative 1/2 and just bring that down, and this is going to become x cubed minus 8 divided by negative 2 x cubed plus 4 to the 3/2. Alright, and then rather than having this negative sign down here, we can just put this negative sign in front of everything. And there you have it, the final answer for the derivative of this function. Okay, so this is a complex one, even though the original problem doesn't look too difficult. There's just a lot of, we have to apply a couple different concepts, we have to apply it well, and we have to simplify it thoroughly, as thoroughly as it can be. Okay. Alrighty, I'm going to do one more example, and then I'll leave you to do this on your own. So the last one here, try that on your own. The next one I will do with you. Okay. So here we have a function h of x equals sine of 3x squared. So again, the outside function and the inside function are what matter here. You got to keep track of those. The outside function is sine of x. So the derivative of this is, well, cosine of x, but it's not really x, it's 3x squared, times the derivative of the inside function, which is just 6x. So our final answer here is actually pretty straightforward. 6x times the cosine of 3x squared. So I leave you to do this last one on your own. Just be careful. This is just think about how many different functions are involved here. Okay, and then check with me in class about this to make sure that you have the right answer. Thank you for watching, and have a wonderful day.